Hello everyone, welcome back to my channel Cat Voyager. This is me Mayanka Chattopadhyay and today I am back with another video. This is day 3 of the series I am going to continue, and this time I have a problem on algebra. So let's get started. The problem is on your screen and it says find the minimum value of two algebraic functions are given in X and containing modulus. So let's see how can we solve such problems. Before solving this, let's understand a thing which is known as critical points. So suppose we have a function in X given by fx equal to sum modulus of x minus a plus x minus b plus x minus c and more such things. So here this value a and this value b, this value c, these are called critical points. So that means your x equal to a, x equal to b, x equal to c, where the value of this function takes a change, or the type of the function changes in these intervals, within these intervals. Okay, so what if you had x plus b in the place of x minus b? Then your critical point would have been x equal to minus b, right? So let's look at the first point, the first question. The first question is your x minus 2 plus mod of x minus 12. So what are your critical points? Your critical points are x equal to 2 and x equal to 12. Now, as these two are critical points, let's take this function by part within these intervals. So what kind of intervals are you having on the number line? If my number line is from x equal to minus infinity to x equal to plus infinity, if this is my real number line, then, and if this is my origin, then 2 lies somewhere here and 12 is somewhere here. So what are my intervals? My intervals are interval 1 is x less than 2. Your interval 2 becomes x greater than equal to 2 less than 12, and your interval 3 becomes x greater than equal to 12. Now let's try to define this particular function within these intervals. So for your interval 1, when your x is less than 2, we have the mod x minus 2 opens with a minus sign. Okay, so if we open that particular mod, it becomes 2 minus x. That means your minus of x minus 2 basically. And in the case of x minus 12, we will have this modulus will open as 12 minus x. So the function we are having in this interval is basically your 2 minus x plus 12 minus x, or equal to 14 minus x. Let's note this thing down. So here we have your 14 minus x. In the case of your second interval, we have x is between 2 and 12. Let's forget about x equal to 2 for now, and let's take the interval x is greater than 2 and less than 12. Okay, so that becomes this modulus, your x minus 2 will open as a positive. So that will be your x minus 2, and your x minus 12 will become negative because in the interval x is less than 12. So it becomes 12 minus x. If you add these two things up, it becomes x gets cancelled out and this is 10. So within your 2 and 12, the value of this particular function is always 10. Whatever value you take 2, put 2 in this function, 2 minus 2 is 0 and 2 minus 12 is minus 10, modulus of minus 10 is 10. And similarly, if you take 12, your 12 minus 2 is 10, modulus of 10 is 10, and this becomes 0. So everything is 10 here. And for x greater than equal to 12, the particular function becomes, both these things will open as positive, and the particular thing becomes 2x, I did a mistake here. This should have been 14 minus 2x. And similarly here it would be 2x minus 14, right? Now let's look at these three things. If we look at a graph, and if we take 2 here and 12 here, suppose this is your x-axis, this is your y-axis, and this is 0. So if we look at this two equations, these are equations of straight lines, okay? And in the first equation we have minus 2 as the slope of x. That means your straight line is kind of like this. That means up till 2 we would be having a line something like this. Between 2 and 12 we have 10. This is your y equal to 10. And after 12 we will have 2x minus 14. Your slope is positive, so this line will be something like this, or from 12 it becomes this. These two lines are exactly have similar properties. They have slope same, so this will become a mirror image from this point, kind of like this. So you can see from the graph easily that your least value or your minimum value of this particular function comes between 2 and 12, and that value is 10. You cannot have more than 10 at any other point. You can check by taking even manual values of x. You take any negative value of x, it will give you more than 14, obviously. And if you take any value greater than 12, this will give you more than 10 always. Suppose if you take 13, this becomes 12. If you take 14, this becomes 14. So yeah, the answer for your first question is 10. Now let's look at the second question. We will try to solve by similar method. So your second question is mod x minus 4 plus mod x plus 3 plus mod x minus 5. The first rule is, let's figure out the critical points. What are the critical points? Minus 3 for this one, 4 for this one, 5 for this one. Put these on the number line, minus infinity to infinity. This is the number line of x. So minus 3 is here, if 0 is somewhere here, this is your 4 and this is your 5 approximately. Now again we will try to figure out the value of the particular function within these bounds. I mean, so what are the intervals? Your intervals are, interval 1 is when your x is less than minus 3. Your interval 2 is when x greater than equal to minus 3 but less than 4. Your interval 3 is when x less than equal to 4 but greater than equal to 4 but less than 5, and your interval 4 becomes your x greater than equals to 5. Let's try to look at the functions in the particular intervals. So when your x is less than minus 3, all these three mods will open as negative. So your first mod becomes 4 minus x, your second mod becomes minus x minus 3, and your third modulus becomes plus 5 minus x. Everything taken together, it gives you something like 4 and minus 3 is 3. Sorry, 4 and minus 3 1 plus 6. This is minus 3x. This is your 6 minus 3x. For the second case, x we have taken as greater than minus 3 but less than 4. So in this interval, this particular modulus will open as positive. So we will have x plus 3 but 4 minus x, and similarly 5 minus x. These two gets cancelled out. 4 and 3 is 7, 7 and 5 is 12. This is your 12 minus x. For the next case, we will have x within the interval 4 to 5. So this and this will open as positives. So this will become x plus 3, the other one will be x minus 4, and the last one will be 5 minus x. This will open as negative. So these two gets cancelled out. 5 minus 4 is 1. This is 4. You will have x plus 4. And for the last case, everything will open as positive because x is greater than all the critical points. So that will be your x minus 4 plus x plus 3 plus x minus 5. This is your 3x minus 6. Okay, so if we try to draw the graph, this is your x-axis, this is your y-axis, this is 0, minus 3 is somewhere here, 4 is here, 5 is here. Okay, so at minus 3, what value we will have? We will have a value, if x is minus 3, then this is 3 3s are 9 and 6, this is 15 somewhere, this is 15. Okay, and this is a line with a negative slope. So a line will come like this and end up at 15. Now from minus 3 to 4, we again have a line with a negative slope, and that means the line is in decreasing direction. At 4, we will have the value, if we plug in 4 here, we will have 12 minus 4 is 8. So from 15 to 8, the line will decrease continuously. This is your 8. From 4 to 5, we have x plus 4, the line with a positive slope. Now at 4, we have 8, 4 plus 4 is 8. At 5, we have 9. So this is like this. This is your 9. Okay, this is your 8, 9. And after 5, we will have a symmetric line like this one. So that is your, let's check if this is continuous. So 5 plus 3 is 8 minus, 5 into 3 is 15 minus 6 is 9. This is your 9. And after that, this is a line with a positive slope of 3. So this will be like this. Okay, so from the graph, you can clearly see that the value is 8 and that is at point A. Okay, so your answer to this question is 8. Now let's think of a process by which we can quickly figure out without even figuring out the lines within intervals. That can be a pretty hectic process, right? So for example, what happens if the number of critical points becomes 4 or 5? You have to figure out the equation of the straight lines in each intervals, and then you have to calculate, and you have to piecewise determine where is the minimum value of the function is going to occur. but we have something to circumnavigate that cumbersome process. So for example, if we have one critical point, suppose let's start by one critical point. If we have one critical point, what do you mean by one critical point? Mod x or mod x plus 1 or mod x minus 2. These are with one critical point. In this case it is 0, it is minus 1, this is 2. How do these functions look? They look something like this. If this is your 0, this is x, this is y, the mod x looks like this, right? Only one sharp notch, if we will say. In case of x equal to minus 1, the notch will be in minus 1, like this. In case of 2, the notch will be at 2. Other things will remain same, like this. Okay. When the number of critical points become 2, like the previous question, we have seen what does the graph look like this, some kind of bucket or a bowl. If number of critical points are 2, we will have 2 notch, as simple as that. So it will be something like this. These 2 will be your critical points. Anything it can be. This is A, this is B. Okay. Now, if number of critical points are 3, if these are 3, we have seen from the graph how many notches we have. This is 1, this is 2, this is 3, right? So the graphs look like something like this, a bucket or a bowl with a pointed bottom. Now by intuition, can you figure out, if we have number of critical points as 4, how will that graph look like? That graph will look something like this. If you have thought something like this, then you are absolutely correct. This is your first notch, second notch, third notch, fourth notch, and these are your critical points. This one, this one, this one, and this one. So where does your maximum value come? In this interval. This line is parallel to your x-axis. Okay. So suppose we have a function given by fx equal to x minus 3 plus x plus 1 plus x plus 6 plus x minus 7. How do you calculate the minimum value of this particular function? How do you calculate? You cannot calculate or figure out all the straight lines in all these intervals. How many intervals you will have? You will have many intervals, right? And that will be very time consuming. So what is the shortest process is that you take the number line. This is your x number line. You put the points in increasing order. So you have minus 6, then you have minus 1, you have plus 3, then you have plus 7. So from this one, we can say that your minimum value will occur at any point within your this interval, because the graph is looking like this, right? So for example, take minus 1. What is the value? This will give you 4, this will give you 0, this will give you 5, and this will give you 8. So you have 8 plus 4 is 12 plus 5 is 17. Let's take 3. This is 0, this is your 4, this is your 9, and this is your 3 minus 7 is minus 4 or 4. So we have 4 plus 4, 8 plus 9, 17. You can take even 0. So this will be 3, this will be 1, this is 6, this is 7. 7 and 3 is 10, 6, 16, 1, 17. Your minimum value is 17. Within a matter of seconds, you can figure this out. Okay. Now, as a proof, let me show you the actual graphs that I have plotted on Desmos. Desmos is an app available on Android if you want to go and check it out. Very handy when it comes to figuring out the graphs. So as you can see, looks like a bucket, right? Looks like a bucket. And in the case of the other question we had, looks like a bucket with a pointed bottom. The 3 critical points are here. These are your critical points. This one, and this one, right? Similarly here, critical points are here and here. Okay. Now you might ask a question in the case of the first problem or like other problems. How did we figure out without solving for the interval and the straight lines that will be in that interval we would have a line parallel to the x-axis? Because what actually does this signify, this whole equation, in terms of your distance? This tells you about a point x and the sum of its distance from a point 2 and a point 12. So on the number line, if we plot 2 here and 12 here, if you take any point in this direction, any point, your distance from 2 is this and your distance from 12 is this, and it keeps on increasing as you take the point in the negative direction. It keeps on increasing, the distance becomes this, and from 12 it becomes this. And similarly for the case on the other hand, if you take any point in this direction, the sum of the distances keep on increasing. Only in the case of the interval within 2 and 12, if you take a point here, x1 suppose, your distance is this from 2 and from 12 is this, right? If you take x2, similar case, distance from 2 is this, from 12 is this. So your distance, sum of the distance between this interval for any 2 points is always your 12 minus 2, 10. That's a constant value. So that's why you always have a straight line which is parallel to the x-axis. So now you have, I hope you have understood the method of solving this one. Try to go by applying, or better to say, try to go by applying this kind of things, or try to visualize the graph. As an exercise, you can think of some function which has 5 critical points. What would the graph, what kind of graph could we have? We could have a graph like start with a pointed bottom, because it's a function with odd number of critical points, right? In the case of 2, we had a flat bottom. In case of 3, we did have pointed. For 4 we had, you can see, for 4 we had a flat, and for 5 that means we would have a pointed. For odd, the general rule is for odd it is pointed, and for even function is flat. So for 5 we would have something like, this is your first critical point, These are your other critical points, other two or three maybe. Then we would have like this is your fourth and this is your fifth, and after that we would have something like this. Graphs are not to be scaled obviously, but yeah, something similar to this you would always have, and it keeps on increasing as you increase the number of critical points. So always when you face this kind of questions related to minima of modulus of functions containing modulus, try to visualize the graph. Just take any trial point within the intervals and solve for that trial point. You will get your answer within a matter of seconds. I hope you enjoyed this video. Tomorrow I will be back with a similar problem on this concept, but on a bit of tougher side, I would say. We will have fun solving that question for sure. That's it for today. So if you understood and liked this video, please do like, share and subscribe and stay tuned for more. I will be back again tomorrow. Thank you guys. Bye bye. Thank you.